This video will review measures of center and spread and focus on mean absolute deviation, or MAD. The measures of center are mean and median. We use mean if there are no outliers, and if there are outliers, we use median. The measures of spread are mean absolute deviation, and we use that if we're using mean for the measure of center. So they're both highlighted here in blue. And the other measure of spread is IQR, or interquartile range. And we use IQR if we've used the median as the measure of center. So we decide which measure of spread to use based on which measure of center we use. And we decide on the center based on whether there are outliers or not. So briefly, I gave you a definition of outliers yesterday, and we talked about using 1.5 times the IQR to figure out whether something's an outlier or not. Today we're going to look at actually how to do that. So I have a simple set of numbers here, and we're going to learn how to check for outliers. The first thing you need to do is identify the quartiles, because of course the goal is to use that interquartile range. And to do that, we need quartile 3 minus quartile 1. So we need what those quartiles are. I start by finding the median, the middle of these. They're already in order, and I can see that the median is 5. All right, the middle of my lower half is going to be 4, and that's my first quartile. The middle of my upper half is 7, and that's quartile 3. So I have my third and first quartiles. I can now figure that my interquartile range is Q3 minus Q1, and that gives me an interquartile range of 3. So here's what we're looking at. If this is a box in the box and whisker plot, the bottom of the box is the first quartile. The top of the box, and when I say bottom and top, I'm sorry, I mean the lower end and the upper end, is 7. And so the median being 5 is probably right around here. What I'm looking at is whether my ends here, the 2 and the 9, most likely would be the ones that I'm deciding whether they're outliers or not. I need to know how far out, how far this way or how far up from the 7 determines an outlier. And so we're going to look at those boundaries. How far can I go until something is considered an outlier? We do that using the IQR times 1.5. It's always being multiplied by 1.5. 3 times 1.5 is 4.5. And of course you can do that in your calculator. So in the formula you were given, it says quartile 1 minus 1.5 times the IQR. What that means is you have to go back from 4. Minus means going backwards, right? If you were on a number line, wouldn't you move to the left? If you went 4 minus 4.5, you'd end up with a lower boundary of negative 0.5. Anything smaller than that would be considered an outlier. Well, 2 is certainly not smaller than that. So we're safe on this end of the data. Now let's look at the 7. If I add 4.5 to my 7, quartile 3 plus 1.5 times the IQR, if I'm going this way, up 4.5, I get to 11.5. Anything bigger than 11.5 would be considered an outlier. There is nothing in my set of data bigger than 11.5, and so there are no outliers. This gets easier with practice, so let's do another one. All right, when we look at this set of data, again, we want to find our quartiles. I know that my median is here. Now I can see that my median is going to be 15.5 or 15.5, but I don't really even care what that number is at the moment because I'm interested in my IQR so I can determine outliers. All right, the middle on this end, I'll use a different color, is between 17 and 20. That's going to be 18.5 for quartile 3. Remember, if it falls between two numbers, you average them. You add them up, divide by 2. And so you get 18.5 when you do that. We'll do the same thing on this end. There are 4 numbers to the left of the median. And so the middle is going to be between 10 and 11, which of course is 10.5 or 10.5. Okay, now we have quartile 3 and quartile 1. The interquartile range subtracts those two numbers, and we get 8 for our interquartile range. Remember that we're going to multiply that by 1.5. And that tells us how far to the left or how far to the right we can go from our box. This is 10.5 at the lower end of the box. This is 18.5 at the upper end of the box. So 8 times 1.5 is 12. And so I can go 12 to the left from 10.5. Which would be negative 1.5. Anything smaller than negative 1.5 in my data would be an outlier. Clearly there's not even any negatives here. And if I start at 18.5 and I go to the right, that's adding the 12. And so then I get 30.5. And I do see a number that's in my data that's bigger than 30.5. So 40 right here is an outlier. And so if we were making the box and whiskers, we wouldn't actually include 40. The top here would be 20, the top whisker. And then 40 would be out here as just a dot by itself. The bottom number is 2, and maybe that's over here. That would be connected by the whisker. When you make a box and whiskers, the outliers would be shown separately. That way it doesn't sort of weight the other information. You'll practice outliers more in class, but remember, if there is an outlier, you're going to use median, and if there is not an outlier, you will use the mean. Those are the measures of center to be used. So if there are no outliers, we're using the mean, and then for spread we're going to use mean absolute deviation, or MAD, and that is the only term that you're not familiar with yet. Deviate is change or difference, and so what we're looking to do is find the difference from the mean for each piece of data. Let me show you the steps. This takes a few steps to do, but they're not particularly hard individually. The first step is to find the mean of the data that you're given. And so you know that mean is average. We're going to add up our data and divide by however many pieces there are. Go ahead and pause and do that now. Okay, so if you found X bar, which is the mean for this data, you had to round it. You should get approximately, 5.4 if we round to 1 decimal place. And that seems about right. Our numbers range between 2 and 9. About 5.4 seems like a reasonable mean. Now, the second step is to make a new list of numbers of the difference between this mean and every piece of the original data. Difference means subtract. What I'm interested in is how far from the mean is each of these numbers. So I don't care about negatives because I'm talking about distance. Distance between 2 and 5.4. How far away are those numbers from each other on a number line? You can find them by subtracting, but go ahead and do it conveniently, the larger one minus the smaller one. So 5.4 minus 2 is 3.4, and that's our new first number in our list. Then I'm going to go ahead and subtract with the second number in the list. 5.4 minus 4 is 1.4. And you're going to keep going. 5.4 minus 5, that's just 0.4. You can do these on your calculator. 5.4 minus 5, you do repeat as many times as it occurs in the original list. You should have the same number of new pieces of data in your new list. Now what happens here? If I go 5.4 minus 6, aren't I going to get a negative? Well, I am, but I'm interested in the distance between these numbers, so I don't care about the negative. I could put it in my calculator this way. 6 minus 5.4. What is 6 minus 5.4? You should get 0.6. And look, you can do the same thing. If you did 5.4 minus 6, you'll still get negative 0.6. What I'm saying is I don't care about the negatives. Distance is always positive. So use your calculator. Finish these last two. Remember, I want positive numbers. Okay, how did you do? The last two numbers in your list should be 1.6 and 3.6. I'm sorry, that's a little hard to read. 3.6. All right, these are our list of differences. I did 7 minus 5.4, got 1.6. I did 9 minus 5.4, I got 3.6. If it helps, you can make a little table out of these, and you'll see that I started you out with that on your worksheet because some students find that a nice way to organize their work. The last step is to find the mean of the differences. All that means is take this new list and find the mean of it. How do we find the mean? We add them all up and we divide by how many there are. How many there are is the same number there was here. There was 7 before and there's still 7. That's always going to be true. If you add up all the numbers, you get 11.4. And then we have to divide by 7 because there are 7 pieces of data in our list. When we do that, we'll have to round our answer, and we get approximately 1.6. 1.6 is our mean absolute deviation. 1.6 is our MAD. It's our measure of spread. Now there are a lot of steps here, I know, but you'll be able to do this with a little practice because it's just finding the mean over and over again. We'll practice this more in class.